Good morning, it's me, your backwards hat wearing, same shirt I always wear, stinky unshowered teacher, but you can't tell any of that because we're in a video right now, and all you hear is my voice. So for all you know, I have changed my clothes, and I might actually have showered, but you'll just have to assume either the best or the worst of me. Nobody knows. Today, what we're going to do is we're going to actually start our trig. So it should be pretty relatively easy day, kind of kick things off. Trig gets a little bit harder in a couple lessons. With practice, people usually get very strong at this section of the trig, which is good. We got to start some things off with some definitions. So we'll read through this. It says for a point on a coordinate plane, just for the record, is like on a graph. Right? So a coordinate plane means a graph. When an angle theta is between 0 and 360 degrees, the angle is measured counterclockwise from the positive axis to the initial arm. This angle is said to be the standard position. Okay, so for example, down here, we have a graph. This is a point on that graph. Awesome. There's a line that connects the center of your graph out to that point. What they're saying is that when you measure angles, you should start from the positive x-axis and go counterclockwise. So starting here, this is the positive x-axis, and going counterclockwise is that way. We call that theta, which is the standard position. Awesome. The second little part, the line joining the point and the origin is called the terminal arm. The point is called the terminal point. So if we look here, we have another one over here. We just have some actual names for these things. So this spot out here, that's the terminal point. Honestly, we don't use that term a lot, maybe a little bit. So that's a terminal point. This line that connects the center of the graph out to the terminal point is called the terminal arm. We do use that phrase a little bit more. Terminal arm. And again, if you wanted to measure the standard angle theta, you start at the positive x-axis and you go counterclockwise until you hit that terminal arm. That would be your angle. So notice that it's not just the closest x-axis, it's the positive x-axis, and that is our standard position angle. Standard position angle. Most of our questions refer to a standard position angle. Okay, couple more definitions. Here we have a Cartesian plane. So a Cartesian plane just means a graph. We have an initial arm. That's a term we don't see a lot of, but initial arm is just the positive x-axis. So sometimes you'll be like, you'll read definitions that say the standard position angle is the initial arm to the terminal arm. It's the positive x-axis, it's the same thing. The terminal arm, we just discussed, is from the center of your graph all the way out to wherever you're pointing to. So in this case, it would be this one right here in blue. That is my terminal arm. Okay, we're going to talk about a few things here. So imagine that your initial arm, this red line right here, it's like I don't know, like a windshield wiper. Like it could move up and down. Like I could take that red arm and I could like swivel it. So if I was to swivel it all the way out to here, like that, this angle I've created when I move that arm is called my standard position angle, theta. Standard position. Okay. That's the standard way we would get from our initial arm to our terminal arm. However, there are more ways to get there. So for instance, I could have taken this angle and I could have gone all the way around. So I could take this like red initial arm and I could spin it all the way around so it does a 360. And then I could go the rest of the way and then stop there. So imagine that red arm, right? It's like spinning. So I could spin it. I guess a good reference would be like a clock, like an arm on a clock. I could spin it, do a full 360, and then I could go the rest of the way out to that terminal arm, that blue line where it stops. That angle that we just created, I'm just going to call it alpha like that. That would be a coterminal angle. It's a coterminal angle because it got me to the same spot. It moved my arm to the same spot. It just did it in a way that wasn't the standard way. And you could do that a million times in a row. You could just keep doing 360s and getting to the same terminal or same standard position angle, the same terminal arm. You could also technically spin backwards. Now, none of these ways are the standard way of doing things, but they are ways of getting to that same spot. So I could take that red arm and I could technically spin it backwards at that angle and then stop at that blue terminal arm. So that is another angle, we'll just call it angle X, that would get me to the same position. It's just not the standard position. And that would still be a coterminal angle because that angle would still get me to the same spot, just not the standard way of getting there. All right, reference angle. A reference angle is an angle between, I'm going to erase those angles right there. So if you need to go back and look at them, that's fine. Just pause the video and go back and erase them because the drawing gets a little convoluted. Your standard position angle is one that gets talked about a lot. It's that blue one. I'm going to leave it there. Your reference angle is the angle between the terminal arm and the closest x-axis. This right here. That angle, which I'm going to call x, is your reference angle. It's always between the terminal arm and the closest x-axis. Sometimes the standard position angle is the reference angle. That's possible. But it's also possible that we have a different standard position angle and a different reference angle. General solution, we don't talk a lot about at this point, but a general solution is just a way to create coterminal angles. So the way that you would do it is if you took your standard position angle. Oh, that's not how you spell standard. Standard. If you took your standard position angle and you added or subtracted 360 degrees, basically you're doing a spin, right? A spin is 360. It would always get you back to the same spot. And you could do that n times. So if your standard position angle was 100 and you added 360, that would get you back to the same spot because it would be 100 plus a spin. If you want to do 2 spins, you do 100 plus 360 times 2 for 2 spins around to get you to that blue spot. This is kind of a weird lesson to be doing without being in person, because normally I would have like things up on the board so you can kind of visualize it a little bit more. Essentially, what we're doing is we're taking a line, okay? Let's see if I can draw it. It starts here at the standard position. If I rotated it like this, that would get me to the standard position angle, the terminal arm. I could then add a full circle to my angle and it would get me to the same spot. So if I went plus 360, it would go all the way around and get stuck there because that's 360. And I could keep creating more angles by adding another spin. Add another 360, it's there. Add another 360, it's there. Add another 360, it's there. I also said subtract 360 because technically you could subtract an angle, which means go the other direction. And if you subtracted a full circle, you would be there. Subtract a full circle, you'd be there. We won't do a lot with our general solution at this point, but just so you kind of have an idea that you can have a lot of coterminal angles here. You can have infinite coterminal angles because you just keep doing an extra spin on your arm. Okay, that's some craziness. We're going to do some basic standard position angles today. We'll always be in quadrant 1, so it'll be kind of nice. This question, they gave you a point out here. They labeled that point x comma y because you don't actually know where it is. X comma y. They then have your standard arm, which is this guy right here, or sorry, your terminal arm right there. And you'll notice that they have labeled your standard position angle right there to your positive x-axis. The first thing they want you to do is to find r. So if you wanted to find r, we did this yesterday. So to find r, you have to realize that we actually have a triangle here. If we were to go straight down from that terminal point and straight across, what you've done is you've created a right angle triangle. And that right angle triangle has side lengths of y and x. Because x is how far you move left to right, y is how far you moved up to down. So if you wanted to find out what r was, you would use Pythagorean Theorem. You'd go r squared equals x squared plus y squared. If you want to take that one step further, you would square root both sides. And we create a formula for finding our r value. That formula is the square root of x squared plus y squared. Essentially, it's Pythagorean Theorem. If you wanted to find theta, which is that angle, then you could use SOHCAHTOA, right? So if we wanted to do it in terms of y and x, this would be my opposite. This would be my adjacent. This would be my hypotenuse. If I'm looking for angle theta using x and y, then I would have to do tangent, because the tangent of theta equals my opposite, which is y, divided by my adjacent, which is x. Cool. If you want to find the x coordinate of something, and you want to use r in your theta, then you would use, what do we want to use? R, which is our hypotenuse, and x, which is our adjacent. So hypotenuse and adjacent would be cosine. We would do the cosine of theta equals adjacent, which is x, divided by hypotenuse, which is r. We could rearrange that formula to be r times the cos of theta equals x. You could also do that for sine to find your y coordinate. So we would go sine of theta equals y over r. This gives us a formula that r times sine of theta will equal your y coordinate. Now, technically, what we've just done is we've created a bunch of formulas to be able to find things. We created one formula up here to be able to find the distance from the origin to our point. We did this formula here, which would help us find theta. We did this formula here, which would help us find our x coordinate of a point. And we did this formula here that would help us create your y coordinate of a point. But in reality, okay, like I never reference these formulas. I never reference them. The reason why is because these things are just SOHCAHTOA. Like if you can do SOHCAHTOA, you can do all the stuff we're going to do in this unit. You don't have to memorize formulas and stuff like that. You just have to remember how to do SOHCAHTOA. This formula up here is just Pythagorean Theorem. All right. Let's try it. We have a question here. It says the point 4, 7. Okay, let's draw that. So 4 over 7 up. I'm going to pretend that point is out here. I'm just randomly picking it. 4, 7. The point P is on a terminal arm. A terminal arm is a line going from the origin to that point. Of an angle theta in standard position, my angle theta in standard position would be right here. Standard position is going to the positive x-axis. Questions we got. First question. Determine the distance from the origin to P. Figure out this distance right here, which we call R. Just for the record, we always call that R in this unit. We'll get more into why it's called R in like 2 days. So figure out that distance R. To be able to figure out that distance R, you need to make a triangle. That triangle is going to be a right angle triangle that goes straight down and straight across. That X value from that point goes right here. That Y value goes right there. To determine the distance, you'd use Pythagorean Theorem. 4 squared plus 7 squared equals R squared. And again, like you could use that formula that we learned on the last slide, but I use Pythagorean Theorem. You throw that in your calculator, 16 plus 49 would be 65 equals R squared. You'd square root both sides to get an answer of square root 65 equals R. Now, for the record, that is the answer we prefer, because that is an exact value. If they asked you to round it, then obviously you could round it. I believe it's going to be 8.1. Let me try it. Yep. So you could round it if it asked you. If it doesn't ask you, though, leave it as a square root of 65. Perfect. We now know that R is the square root of 65. And I don't think you can simplify that. If you could simplify it, you would. So, for instance, simplifying radicals, right? Dividing by perfect squares. I don't think anything divides into 65, though. Awesome. Determine the 3 primary trigonomic ratios. Okay, the 3 primary trigonomic ratios are sine of theta, cos of theta, tan of theta. Those are the 3 primary trigonomic ratios. If you want to do those primary trigonomic ratios, you have to remember SOHCAHTOA. Sine is equal to opposite divided by hypotenuse. If you go back to our triangle, this is my opposite, this is my hypotenuse. This means that the primary trigonomic ratio sine is equal to 7 divided by root 65. Cos is adjacent over hypotenuse. So if you want to do the cos of something, it would be the adjacent, which is 4, divided by root 65. The tangent is opposite divided by adjacent. Opposite is 7. Adjacent is 4. Those are your 3 primary trigonomic ratios. I want you to just take a second, make sure you understand how I got those. I use SOHCAHTOA. Make sure that all makes sense. Notice that I'm not calculating theta. I'm not finding the angle. I'm just doing the ratios, which is the division statements. Cool. Hopefully that makes sense, because I'm about to make it harder. The reason we need to make this a little bit harder is if you look at your ratios, we're breaking a math rule that we know. The math rule that we know is that you cannot have square roots on the bottom. This square root 65 has to get off the bottom. We do that by rationalizing our denominator. So we are going to multiply the top and the bottom by root 65. That's a unit 1 strategy. Remember, we cannot have answers with radicals on the bottom. Therefore, my correct answer is 7 times root 65 divided by square root of 65 times square root of 65 is 65. That's my sine ratio. That would be my first answer. My second answer would be cos of 4 over 65 is not allowed. We need to rationalize our denominator. We need to multiply the top and the bottom by root 65. This will give us an answer now that cos of theta equals 4 root 65 over 65. I have no idea why I'm doing these questions in this bright green, but I made a bad decision and I've stuck to it, like growing a beard. All right, if you look over here, we have tangent of 7 over 4. That is not breaking any math rules. That can stay as our primary trigonomic ratio. Except my box is terrible, so I should fix that. Those are my 3 primary trigonomic ratios. When you see that phrase, you are not solving for theta. You're not finding an angle. You are creating fractions. You're doing either opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. You are not calculating decimals or angles or anything like that. Just the fractions. Awesome. For part C, it says determine the measure of theta. To figure out theta, you can use any of the 3 primary trigonomic ratios. If you took any of them and you did second sine or second cos or second tangent, it would work. I'm going to do tangent because the numbers 7 over 4 are the easiest. Remember, to find an angle, you go second and then tan. And you could have done this with sine or cos. And then you put the fraction inside the brackets, and that will tell you the measure of your angle. If I go second tan, 7 divided by 4, I get 60 degrees. If you used any of those primary trigonomic ratios, they would all equal 60 degrees. Every one of them. Awesome. That's a pretty standard question to be able to do. To be able to find the distance between the origin and a point, to be able to set up the primary trigonomic ratios, to be able to calculate the missing angle. This question is for you to try. So I want you to pause the video and try your absolute best on it all the way through, see if you got the right answer, and then I will go through and finish it as well. Good luck. So hopefully you did that. I'll go pretty quick. You have point 3, 4, so that's out here somewhere. That's at 3, 4. We have a line. That line would be the terminal arm. It goes from the center out to that point. If we want to determine the distance from the center to that point, which is what it's asking you to do, you need to create a triangle. You create that triangle by going straight down and straight across, and recognizing that these points are actually the values to your triangle. And this is called R. The first thing you should have done was Pythagorean Theorem to figure out that R value. So you should have R squared equals 3 squared plus 4 squared. You should have had R squared equals 25. You should have square rooted both sides to get R equals 5. And now we have our triangle. Part B, determine the primary trigonomic ratios. That means you need to figure out what sine of theta equals, what cos of theta equals, and what tan of theta equals. You do that by using SOHCAHTOA. If you don't remember SOHCAHTOA, you need to go watch the last lesson again and do some more practice and ask some questions. Sine is opposite, which is 4, divided by hypotenuse, which is 5. So the sine ratio is 4 over 5. The cos ratio is adjacent, which is 3, divided by the hypotenuse, which is 5. And the tangent ratio is opposite, which is 4, divided by adjacent, which is 3. Those should have been your 3 primary trigonomic ratios. Notice that I left them as fractions. I'm not actually calculating anything. I didn't find angles. I didn't do any of that. I just set up my trigonomic ratios. Part C, determine the measure of theta. To find or determine theta, then you would have had to do second sine, second cos, or second tan. Any of the 3 work. I'm just going to do second cos for the fun of it. So you should have had cos with a little -1. I keep calling it second cos because that's the buttons you have to hit on your calculator, right? You hit second and then the cos button. The fraction or the ratio then goes inside the brackets, so 3/5, and that will tell you your alpha value. If you calculate that, I should know this, but I don't, it gives you 53 degrees. Awesome. Hopefully you got that right. We got 2 questions left. 2 questions left? Yeah, 2 questions. And one of them you're going to do on your own. Beautiful. Okay, so this question says the angle theta is in standard position in quadrant 1. Tan of theta equals 2/7. What are sine of theta and cos of theta? Okay, not much info given to us there. So we got to take that little bit of info and kind of dissect it a little bit. Let's start off with it saying this, the angle theta in standard position. That is very key to us. And they told us what quadrant it's in. So what that means is that somewhere in quadrant 1, there's an angle that creates a standard position angle. Like that. We don't know where it is, but we know that exists. Awesome. The next thing they tell us is that tan of theta equals 2/7. Well, what do I know about tan? I know that tan of theta equals opposite over adjacent. That's what I know about tangent. So if I think about this question, that means if I was to create a triangle by going out here and saying, all right, let's go straight down and straight across, this triangle would have an opposite, it would have an adjacent, and it would have a hypotenuse. And they just told me that the opposite and the adjacent are 2 and 7. Notice that they've given you information. When they give you a ratio, they're actually giving you 2 sides of a triangle. They are telling you the opposite equals 2. They're telling you the adjacent equals 7. And now you have a triangle with enough information to figure everything out. If you have 2 sides, you can find the third side. You have 3 sides, you can do all the ratios, and you can find a missing angle. So when they give you one of the primary trigonomic ratios, you need to build a triangle out of it and then try to complete that triangle. This question says, what are sine and cos? Okay, well, I know that sine, my computer is very slow right now. Sine of theta equals opposite over hypotenuse. If I look at this triangle, I know that sine of theta equals 2, which is the opposite, divided by a hypotenuse that I don't know. Right? I don't know what that is. So to solve that, I'm going to do Pythagorean Theorem. 2 squared plus 7 squared would tell me what that value is, that r squared. That should be 56 equals r squared. That means the square root of 56 equals r. Awesome. And now, to make our day a little bit more fun, because why not have more fun on a beautiful Tuesday? We need to remember to simplify that radical. The square root of 56 can break up to be the square root of 4 times the square root of 14. Which means it is 2 root 14. My computer is falling apart on me, people. 2 root 14. There we go. Remember, that's unit 1, simplifying radicals. So square root of 56, break it into a perfect square and another number. Calculate that perfect square. Now that I know what my r is, I now know my hypotenuse value. I know that it is 2 root 14. Therefore, I know that my sine of theta is 2 divided by 2 root 14. Awesome. This thing can do some simplifying. The first thing I'm going to do is I'm going to recognize there's a square root on the bottom. Or actually, the first thing I'm going to realize is that these two 2's can simplify. They're both monomials. They both divide by 2, leaving me with a 1 root 14. So I have sine of theta equals 1 over root 14. The next thing I'm going to realize is that I can't have square roots on the bottom, so I need to rationalize the denominator. That's what it's called. You multiply the top and the bottom by root 14. By doing that, you get your sine ratio. Sine of theta equals root 14 over 14. That is our first answer. We can also do cos. So cos of theta, I'm just going to draw a line to break this up. Equals adjacent over hypotenuse. That means cos of theta equals, if we look at our triangle, adjacent is 7. Hypotenuse is 2 root 14. Looking at that, I need to do some simplifying. The 7 and the 2 this time don't divide into each other, but we still have to get rid of that root 14, so we multiply the top and the bottom by root 14. Notice that I'm not multiplying by 2 root 14, I'm just multiplying by root 14 to get rid of that square root 14. This gives me cos theta equals 7 root 14. Oh man, my computer right now is struggling hard. I apologize. This is going to drag out this video pretty hard right now. Cos of theta equals 7 root 14 divided by. Now, on the bottom, this is a little trickier. That 2 is going to stay a 2. The root 14 times root 14 becomes 14, like that. Awesome. Then I'm going to simplify that. So it'll be 7 root 14 divided by 28. You know you're done when you're following all your math rules, which means there's no square roots on the bottom, and you can't simplify. If you look at this question, the 7 and the 28 can simplify. They can both divide by 7. This gives me a final answer of cos theta equals root 14 over 4. Notice that I did not divide the 14 by 7 because that 14 is part of a radical. It is not a monomial, so it cannot cancel with that 28. Those are my two other ratios. Sine of theta equals root 14 over 14. Cos of theta equals root 14 over 4. Whew. And my computer is basically done doing math for the day by the looks of it. So I'll zoom out a little bit so you can see that question nicely in full. Gorgeous. All right, the next slide is a practice question very similar to this question. I want you to pause, see if you can set it up, and then unpause. I'll go through it and hopefully get you the right answer. Cool. Okay, hopefully you pause this thing. What you needed to do to start this question off is realize that we had an angle in standard position. What this means is that we have some sort of terminal arm coming out of the origin that has created a standard position angle in the first quadrant like that. Then you needed to realize that when they told you that cos equals 5 over 13, they were giving you two sides of a triangle. The reason why is because we know that cos is equal to adjacent over hypotenuse. Oh, come on. Chromebook. Maybe my Chromebook has senses and it can smell how bad I smell right now, because that would make sense, and it's fighting back the best way it knows how. Oh, it won't even let me erase. It is angry, people. If technology could fight back. This is like, maybe this is how I Am Legend started. Cos equals adjacent over hypotenuse. Awesome. Now we can build a triangle because we know that those two sides, adjacent and hypotenuse, connect. This connects to this ratio they gave me. They told me the adjacent is 5. This is the adjacent. They told me the hypotenuse is 13. There's your hypotenuse. Now we have a triangle with two sides. We can find the third side, and then we can do everything. To find the third side, I'm going to try to go a little bit quicker here. Actually, I'm going to pause the video, and then the answers will just appear for you. Ta-da! And no magic. It's all there. So the first thing I did was in green. I had to find that third side of that triangle. I did that using Pythagorean Theorem. Pythagorean Theorem for this case would be 13 squared minus 5 squared. That'd be c squared minus a squared. That gives me 144. The square root of 144 is 12. Therefore, my missing side, which I called y, is 12. The reason I called it y is because if we think of that as a point, that would be my y value, right? From the bottom going up to the top of that triangle. I then went ahead and did SOHCAHTOA to get my two ratios. So sine of theta is opposite over hypotenuse. Opposite is 12. Hypotenuse 13. So 12 over 13 is my answer. I cannot simplify. It is done. My tangent ratio is opposite over adjacent, so opposite would be 12, adjacent would be 5. 12 over 5 would be my final answer. We survived. My computer hates me. Hopefully you love math as much as, I don't know, somebody who loves math. All right, take care all. I will see you soon. Bye-bye.